Hello everyone. It's the time to sleep, but someone student has asked me a problem how to find the work done in isothermal and adiabatic process. Certainly, I have to wake up and give the reply because without giving the answer, I can't sleep. This is my drawback. It is my problem. So today I am going to explain how to find work done during isothermal and adiabatic process. But before we start that thing, first of all, you have to know work done in any process whenever the volume is going to be changed. So work done is equal to integral P dV. This is the formula. But the main question which comes in your mind is, how do we get this result? So for this result, we are going to prove it. Let us consider a container having area of cross section A with a piston which is tightly fitted inside it, but without friction, it is freely movable. Area of the piston is A. The pressure of the system, pressure of the gas is P. Due to pressure exerted by the gas, the piston lifts up by a distance dx. Now we have to find the work done. We know that work done will be dW because the displacement is very small. We have shown it up to large distance because otherwise you will not be able to find it. You will not be able to see it in your videos. Therefore, I have shown it like a large distance, but it is very small distance. It is thinner than our hair. dW is equal to F dx, force into displacement. Force is F, displacement is dx. But the force is equal to pressure into area. Therefore, dW will be pressure into ADX. ADX, area into dx, will be this volume. We know it, the volume of any cylindrical surface will be A dx. So A dx is going to be dV. Why do we call it dV? Because this is displacement is very small, therefore this volume is very small, we can call it as dV. It is dW. Now integrated both the side, you will get W is equal to integral P dV. This is the formula for the work done during the expansion of any gas. Now next step is to find work done during isothermal and adiabatic process. Please consider each and every statement given by me. Obviously, I am in the mind to sleep. I was just going to sleep, but the main point is you understand it. Now, if the process is isothermal, in isothermal process, PV is equal to constant. That is PV is equal to nRT. We know that this formula is applicable for each and every process, whether it is isothermal, adiabatic, isochoric, isobaric, whatever is the process. So PV is equal to nRT. So P is equal to nRT upon V. Now we have to find the work done in a process, in isothermal process in which the volume increases from V1 to V2. So work done is going to be integral P dV. Instead of P, I write nRT upon V dV. Because these are constant, so nRT can be taken out. Integral 1 upon V dV. Limit of integration will be from V1 to V2. Now, PV is equal to nRT is applicable for each and every process, whether it is isothermal or adiabatic or whatever. Therefore, P is equal to nRT upon V. Work done is integral P dV. P is equal to nRT upon V. nRT can be taken constant. Number of moles is a constant. R is universal gas constant. T is temperature. In isothermal process, temperature is a constant. Therefore, nRT is a constant. Integral 1 upon V dV. Now, what do we get? nRT log V2 V. Integral 1 upon dx is 1 upon x dx is log x. So, integral 1 upon V dV is log V. Limit V1 to V2. But remember, integral 1 upon x dx is log x base E. Here base is E. That sometimes it is written as ln, but I will write log base E. Log base E. Now put the values. What do we get? nRT log V2 minus log V1. Firstly we put the upper limit, then we put the lower limit. Instead of V I have written V2, then I have written V1. Now put it in bracket. We know that log V2 minus log V1 will be log V2 upon V1. Log A minus log B is equal to log A upon B. The formula for work done in isothermal process is going to be nRT log V2 upon V1, but it is base E. Whatever is your value, you have to see the log table. But all log tables present in class 11th and 12th, whatever are given in board exams, are based on base 10. Therefore, we must write 2.3026 nRT log V2 upon V1. Now it is base 10. So we can write it is 2.3026 nRT log V2 upon V1. There is no need to write the base now, because whenever no base is written in India, it means it is base 10. Okay, base के बारे में मैं आपको एक लाइन बोल दूं. Whenever it is written log A base 10 is equal to B, it means 10 raised to power B is equal to A. Whenever it is written log A base E is equal to B, then it means E raised to power B is equal to A. That means there is lot of difference in base. For example, suppose I ask log 16, what is the value of log 16? Log 16, what is the value of log 16? So it depends upon the base. Suppose it is base 2, so that means it is 4, because 2 raised to power 4 is equal to 16. But it is base 4, so answer is 2, because 4 raised to power 2 is 16. Or suppose base is written 1, so its answer is 1. Base is 16, so answer is 1, because 16 raised to power 1 is equal to 16. We know that 2 raised to power 4 is 16, 4 raised to power 2 is 16. Suppose we don't write base, then our answer will be senseless. So therefore, you must write the base, what base you are taking. Now, this is work done during isothermal process. Now we have to find the work done in adiabatic process. To find the work done in adiabatic process, we are going to perform next operation. In adiabatic process, PV raised to power gamma is equal to constant. Here I have written PV is equal to constant, but in adiabatic process, PV raised to power gamma is equal to constant. मुझे माफ कर देना, सोने वाला हूं लेकिन फिर भी पढ़ा रहा हूं. तो बेटा वर्क डन नाउ adiabatic process. Adiabatic process. Tell me, in adiabatic process, PV raised to power gamma is equal to constant. Suppose I put P1 V1, then it is K. I put P2 V2, that is equal to K. But suppose someone writes it is K1, it is K2, that means it is not a constant. Suppose P1 V1 raised to power gamma has different value, P2 V2 raised to power gamma has different value, that means it is not going to be constant. So it is K, it is K. ये मैं क्यों बता रहा हूं? Because whenever we are going to solve this derivation, we have to use these two equations. Now work done. Work done in adiabatic process, whenever the volume expands from V1 to V2, work done is equal to integral P dV. Volume is increasing or decreasing from V1 to V2. Instead of P, we can write K upon V raised to power gamma dV. Okay, little bit slowly. K is a constant, so integral V raised to power minus gamma dV. Now we know the formula, integral x raised to power n is equal to x raised to power n plus 1 upon n plus 1. So integral V raised to power minus gamma has value V raised to power minus gamma plus 1 upon minus gamma plus 1. Now limit of integration from the beginning till now is V1 and V2. Whether I write or I forgot, you must write V1 and V2. Now open the bracket. When we open the bracket, we get K, put firstly V2. So V2 raised to power minus gamma plus 1 minus, instead of V, put V1. So V1 raised to power minus gamma plus 1. Okay, divided by is minus gamma plus 1, that is written here. Minus gamma plus 1. जरा ध्यान दें, PdV P is K upon V raised power gamma. From this equation, this is the main equation which was discussed in last video. K upon V raised power gamma dV. So K is taken out. V1 upon V raised power gamma can be written as V raised power minus gamma. Now V raised power minus gamma by using this formula becomes V raised power minus gamma plus 1 upon minus gamma plus 1. So we get it. Put the value instead of V, firstly write V2, then instead of V, then write V1, then subtract it. So what do we get? K V2 raised power minus gamma plus 1, K V1 raised power minus gamma plus 1 divided by minus gamma plus 1. Now the main turning point of the derivation, K is the constant. Instead of K, I can put it. Instead of K, I can put that. But we will put that value which will give us benefit. Here, instead of K, I am going to write P2 V2 raised power gamma so that powers of V2 will be added. Here, instead of K, I will put P1 V1 raised power gamma. Therefore, powers of V1 will be added. Suppose here, instead of K, I write that value. Instead of K, I write this value. Then the term will become complicated. Whenever we are putting the values, we have to simplify it. So first K will be replaced by P2 V2 raised power gamma, and now V2 raised power minus gamma plus 1. Instead of this K, I will put P1 V1 raised power gamma, and next is V1 raised power minus gamma plus 1 divided by minus gamma plus 1. Open the bracket. Solve the equation. Sorry, instead of saying open the bracket, we must say solve the equation. So it is P2 V2 because whenever powers are added, gamma and minus gamma will be cancelled. It becomes P2 V2 minus P1 V1 upon minus gamma plus 1. Okay. P2 V2 is nRT2 because we know that PV is equal to nRT, in which number of mole is a constant, R is universal gas constant. So P2 V2 is equal to nRT2 minus P1 V1 is nRT1 divided by minus gamma plus 1. Can we take something common? Yes, nR is common. Inside bracket it is T2 minus T1 divided by minus gamma plus 1. Finally, what should we do? nR. I take minus common here and it converts in T1 minus T2. I take minus common here. It becomes gamma minus 1. So final formula is nR T1 minus T2 upon gamma minus 1. This is the formula to find the work done during any adiabatic process. This is the formula. The main question is, why should we take minus common? Here it was T2 minus T1 minus gamma plus 1. Listen, gamma is Cp upon Cv. In my previous videos, you have seen that value of gamma is always greater than 1 because Cp is more than Cv. So if gamma is more than 1, so I just want to put it before 1. Therefore, this result should be positive. Now, work done is nR T1 minus T2 upon gamma minus 1. Now, second question is, if equation PV is equal to nRT is applicable to each and every process, then instead of this P, why don't we put nRT upon V? Listen, PV is equal to nRT is applicable everywhere. We can put nRT upon V instead of P in any equation. Now the point, as we did in isothermal process, instead of P, we put nRT upon V, then solved it. But here we didn't do it. Reason, nRT upon V, nR will be taken common, T and V both are variable. It is not isothermal process, temperature will be variable, volume is variable. If two variables are there, it will be very difficult to solve such kind of equation. Therefore, we are not going to use this equation. We will consider that method in which only one variable is left and we reach till the end. Okay, now it's the time to say good night. Feeling sleepy? Meet you in next video. Please forward it, share it, like it, comment it if you liked it. Okay, bye bye.